didn't want India to be known to be a place where cheap products get built. We wanted to be faster, better, but not necessarily cheaper. AI is a commodity, it's an API away. The real differentiator is your ability to get high value ground truth data. As a startup, most of the time you go middle up, whereas in large organizations, you really come top down, right? So there's a big difference in what the promise is. A very symbiotic relationship between the gray haired electromechanical guys and the ponytailed digital AI guys across markets would be huge. I always found the startups to be much ahead of the curve than the internal digital teams of large electromechanical corporations.
All right, we're happy to have Derick here for the latest installment of this series. Derick is here to talk about the nuts and bolts of AI in manufacturing. They've been doing AI in manufacturing from before when it was cool and all the cool kids rushed in. Derick's had a fabulous run selling Flutura to Accenture very recently, a few years ago, and then now 1.5 years ago. And then now he's working on AI in Accenture with, I guess, global customers. So this is fantastic, Derick. Brilliant to have you here.
Thank you.
Can we take a couple of minutes? Can you just do a quick intro of yourself and how did you get here?
Okay. So I Derick Jose, currently look at industrial AI products within Accenture globally. Prior to this, I was part of the co-founding team of Flutura along with Krishna and Srikanth. We started Flutura in 2012. So the guiding principle was simple. We wanted to do a product-based play in AI. We saw industrial AI was less crowded than consumer AI, so we decided to go there. And the second thing is we didn't want India to be known to be a place where cheap products get built. We wanted to be faster, better, but not necessarily cheaper. So those were the two guiding principles. We had a good run. We worked in the energy space, worked in the manufacturing space, and currently it's really catching up. I'm very excited to be here.
Awesome. Brilliant to have you here. We're hoping for some insights across this varied journey, right? So, if we look at the journey with Flutura and then with Accenture, and you've been looking at this for a decade almost, right, or more.
Yeah.
How has AI in manufacturing evolved across the time in Flutura and then Accenture?
Sure. So we started this a little early, 2012. We were a little ahead of the game, even before the language to express the solution space was there, or the category itself was there. So there are no words like digital twin those days. So if you look at it on multiple dimensions, right? So 10 years back, I think we were tapping into an innovation budget. Today we are tapping into hardcore operational budgets. So that's one big change. So it's really gone mainstream. Earlier, we were not focused on CPG manufacturing and to some extent energy side of things. They were the early adopters of AI in the industrial space, so to speak. Chemical manufacturing, for example. Today, if you go to see, even the laggards are adopting, for example, mining and utilities. They don't change too fast, and those spaces are also. So that's one big change. The breadth of industries has also increased. The third important element is earlier, primarily it was the Middle East and US. At least in Flutura, most of the time we focus on Middle East and US because they had the money to spend. And today we are seeing that's gone beyond those two markets. We're now selling to LATAM. We're talking to a mining company in Africa, Australia. So the breadth of markets, the breadth of industries has significantly increased, and I think those are some of the most important changes we are seeing from earlier sell to this. And the size of the deal is also changing. Earlier, I think primarily we are selling products and features. Today, I think it goes as a part of a mega deal. So there is a product, there is services, and there are outcomes. So there are certain deals which have a hybrid of outcomes and product-based license. I would say. Yeah.
That's great. So that's from a buyer perspective, right? How the buyers have changed and which segments are buying, and also how much they're ready to pay you to buy, because earlier they were getting a product and then they would have to figure out how to use it and figure out how can they get benefit from it. Now it's being sold as a solution, and And we'll come into the difference of that later. But just from what kind of AI is being sold, and what is the, if I have to say, like, what were the data challenges that you had before, and what are the data challenges that you have today? Has there been any shift in those two things, the data and what kind of AI and ML are people ready to buy?
So I'll break it down in three parts. One is the use case, the second is the input to it, which is the data, and then the kinds of techniques we do. So from a use case perspective, uh, earlier it was primarily focused on, I would say, buckets of use cases. One is asset intelligence, the other is product quality intelligence, right? So if a batch fails, I want to understand what are the root causes for it, and can I predict the future for it? Or if an equipment fails, a boiler fails or a chiller fails, what is the next best action to take prior to it failing itself, right? So those are two buckets of use cases. But today we are seeing a slightly different class of use cases emerge, very advanced. For example, corrosion is the cancer in the refining industry, the chemicals manufacturing industry. Any chemical goes through a tube, it starts corroding. They spend millions of dollars trying to prevent corrosion or handle corrosion itself. So there's a lot of work happening in corrosion AI, and it's a huge area of spend, especially in the chemicals manufacturing and refining space. The second area which we are seeing emerge is, especially in the chemical manufacturing, emissions related, methane emissions, right? There are Europe is very tight on it, so budgets are set aside to ensure that they don't pay penalties on that. So image-based AI, I would say, for emission monitoring. The third important bucket of use case we are seeing is related to energy consumption itself. Chemical industries, chemical manufacturing industries, a big component of their spend is the fuel cost. And there are bad actors, the very aged assets, which are guzzling too much of energy, and energy monitoring, stuff like that. And for certain very dangerous manufacturing operations, nuclear energy, for example, power generation side of things, and let's say chemical manufacturing, refining, I think safety, worker safety oriented thing, right? Image based, activity based detection and stuff like that. So earlier it was just asset and process. Today it's emission, corrosion, safety, energy. So that's on the use case side of things, right? Data, I agree with you. So AI is in my mind, I always say AI is a commodity. It's an API away, right? The real differentiator is your ability to get high value ground truth data. So for example, in the corrosion space, getting access to labeled corrosion data itself. So there are different types of corrosion, right? Surface corrosion, inner corrosion, underground corrosion. Just getting critical mass of these different flavors of corrosion is a huge challenge, and government of India has taken a big initiative in that direction, where they're trying to assemble the largest data bank of corrosion data in India itself.
Wow, nice.
Yeah, so data exchange, so to speak. So there are these vertical data exchanges getting built to solve high value problems like corrosion. I'm sure
Wow,
after
nice.
some time emission will come up, because corrosion and emission are really, really high value problems which manufacturing industry has to
And there are
focus on.
societal problems as well.
Absolutely, absolutely. And there are places where data was not a problem, because I'll just take an example, right? So we were doing some work for BHL Trichy, boiler manufacturing. A huge part of what they do is welding. So boiler is as strong as the weakest weld. So every time they weld something, they do a lot of radiological examination of that, non-destructive testing. So radiological data was available, and every time weld fails, they had done root cause analysis and documented it on paper in Tamil for 15
Wow,
years.
wow.
Okay, so that was one extreme case where data was available. So that when we went to meet them, and this was before the days of generative AI and stuff like that, they showed us a whole room full of handwritten files and said, "We have the largest database of welding defect data in the world for high
Wow.
pressure boiler manufacturing in Trichy." Okay, and they said, can you do something about it? So it was basically an OCR problem and a language translation problem. But that was how they were thinking about it. So you have two ends of the spectrum. There are certain industries where corrosion and emission with data itself is a challenge. There are other places where people have been very rigorous about documenting stuff, but it doesn't exist in the shape and form which we need. But today, if you ask me, if we go to a BHL, we can get it OCR'd in a month's time, and they can use LLM models and translation. We can build a simple Q&A model to say, hey, what are the learnings? Summarize the learnings from this type of porosity effect for the last 15 years. It'll do it for me right now. But earlier it was unconceivable. So those are the possibilities which are getting unlocked, I would say, in terms of this. Yeah.
So in terms of when we look at this a little more deeply, right, in terms of what people are ready to buy and what data was there and so on and so forth. 5 years ago, 7 years ago, when you were trying to sell stuff as Flutura versus Accenture today, what's the limitations that were there that are not there anymore? What are the challenges that were there that are not there anymore?
Yeah. So primarily, I think as a startup, most of the time you go middle up, whereas in large organizations you really come top down, right? So there's a big difference in what the promise is. So when you're coming top down, there is a bias towards outcome based selling for certain processes or even activity based costing kind of stuff. Whereas when you're going middle up, I think it was always a product sell. So there was a friction in terms of somebody in the middle getting convinced about it, and they taking the onus of articulating the value to the senior leadership. Okay, because in a way we had to outsource the value communication, and we couldn't access the right levels there. So there was a challenge in that. And again, I think in the last 3 years, I would say, they've really set aside money for digital and AI in the industrial space. Many companies have never even set aside money for that, right? So most of the time it will be a POC and a graveyard after that, right? Nothing happens. But that is changing. Budget allocation is changing. The level at which it is being sold is also changing, and there's a different angle. I think today, one of the largest opportunities, at least for the young Indian startups out here, is actually trying to have a partnership with a new business model. I'll explain what that with an example is. So we had, as Flutura, we had a tie-up with the largest manufacturer of subsea equipment in the US. So they used to sell equipment to the drilling companies in Saudi Arabia, Abu Dhabi, etc. Triple digit transactions, $1 million, very large transactions. And what they very clearly said was, look, we know our electromechanical hydraulic stuff the best. We are not the best on digital. So what they said is, give us your product Cerebra, and they will label it. And every time they sell $100 million+ deal, ours goes in as a line item. That okay. And their objective was to earn at least 8 to 12% of revenue from those value-added services. And if you look at most OEMs, whether it's Siemens, whether it's Schneider, whether it's Honeywell, many of them have set aside a target of getting 8 to 12%, anywhere between 8 to 12% from digital services. It could be diagnostics of a service, alerts as a service, prognostics of a service, very flavors of that. But data, AI, diagnostics becoming core to get an additional line item in the revenue stream. And many of them are not great at creating digital products. They're very good at what they do, electrical, mechanical stuff, but the digital stuff and AI stuff, I think the young startups are much better. So I think a very symbiotic relationship between the gray-haired electromechanical guys and the ponytailed digital AI guys across markets would be huge. And there is a lot of these high-value assets being sold. So essentially, they become your channel partner. The OEM becomes your channel partner, and there are some organizations where they have their own digital and internal teams. But in my experience, I always found the startups to be much ahead of the curve than the internal digital teams of large electromechanical solutions.
Got it. So then when we look at the second part, right, which is the last 2 years, obviously AI and what it was and what it is have completely changed, right? What you could do with AI 2 years ago and what you can do with AI today are vastly different, right? So from that context, when you see from a manufacturing context, is there anything specific that has changed in AI that has made use cases that are possible today that were not possible before? And if you had to give a rough estimate of value creation with AI 3 years ago to value creation with AI now? What is the kind of a delta there?
So I'll take two examples. I think one big shift which today is being getting powered is earlier it was single dimensional data, could be sensor visual. Today it's multimodal data. Today you're able to integrate few sensor data with vision data with even voice data. And I'll take a very concrete example for that. So we are working with this large heavy truck manufacturing company, and they have 12,000 technicians. 12,000 technicians troubleshooting heavy equipments every day, and it takes an average of 2.5 to 3 hours to troubleshoot an equipment once they go there. So imagine 12,000 people looking at a truck, observing the symptoms, and hacking it out. There are a lot of things which are not there in the SOP documents these guys do, which doesn't come to the head office. And they do have SAP ticketing firm. Nobody types it in. In an industrial setting, they'll put just one line item there. Now today, what you can do is you can record the voice in Hindi or Tamil or Telugu. He can say, "Hey, look, I'm seeing white fumes come out of the this thing, and I tried this, it didn't work. I tried this, it did not work." So imagine 12,000 field actions getting harvested every day for 5 years, right? That's gold mine, right? So this tribal knowledge has never been codified and analyzed. So what I call the field action loggers, right? Action is happening on the field. A human and a machine are interacting together. They're doing stuff. A lot of that stuff doesn't get captured. It just goes. That institutional knowledge goes. Today, voice makes it frictionless, and so if I can say, hey, I'm observing white smoke in this truck. What are the top 5 things the best troubleshooters have done across India? And I could get it out. And when did they do it? And can I talk to him? Right? All of those things are possible. So that's one thing on the multimodal data side. You're able to get, and similar thing in CPG manufacturing also. When a batch fails, there are shift actions which are taken. They go and change the set points of an equipment. They change the RPM, of the conveyor belt. And all these actions sometimes are logged in paper, sometimes you can get it through a voice file, but those tiny actions on the ground every day matters a lot, and that is correlated to failures. And the ability to process that is a huge possibility today, I would say. That's number one. Number two, if you look at it, the so today you have your traditional vision intelligence, what I call, which is electro-optical, which can look at the surface level defects. But today you have a vast variety of inspections. It could be spectral imaging, hyperspectral imaging. It could be lidar. It could be thermal on drones. So, for example, one of the places is on a power grid. We have drone-mounted cameras which are looking at power spikes, thermal spikes.
Wow.
Yeah, yeah. Today, if you look at CPG manufacturing, for example, shampoo, right, mayonnaise, right, these are all viscous fluids which are getting manufactured, and capturing the chemical constitution and the viscosity of it is closely tied to the quality of the batch itself. Inferring viscosity using spectral cameras, today you can do that. Earlier you couldn't do. This processing power, this sensing technology. So these are the two buckets of use cases, I would say: harvesting tribal knowledge and enhancing deeper inspection of manufacturing processes through non-electro-optical AI, as I would call it.
Wow, nice, man. And from a value perspective, right? If you had to think about dollar value, what's the like a delta here?
Okay, so I'll give an order of and this was the feedback which came from the OEM, right? They said we have 12,000 people to troubleshoot it. If we have this Gen AI based troubleshooter agent, okay, their estimate is they could go down to 8,000 people. Okay, what they're saying is this troubleshooter can be the first, I would say, point of contact and to help troubleshoot. And if the agent can't troubleshoot, you just pass it on to the thing. Okay, so order of magnitude is roughly about like 25% roughly you can shave off from a cost perspective. Uh, that will translate, of course. The other is the mean MTTR, as they look at mean time to repair, which is today is like roughly about 2.5 3 hours. They think it can come down to less than an hour because you have the best guys troubleshooting tips at your fingertips. Okay, and so that's one in the troubleshooting industry. If you look at it from an high precision manufacturing, right, these boiler manufacturing, for example. Like they make the whole boiler, they shift it to the site, and at the site they notice there's a external investor who find out, "Hey, this weld is not proper. I'm rejecting the whole thing. It's too
Oh my
expensive."
God.
Actually, right? And so all of those can be prevented, especially for complex equipments like crude distillation units, boilers, chillers, etc. And yeah, I mean, exact numbers I don't have, but you get the order of magnitude of that. Yeah,
Yeah, and this is just at one place, right? If
yeah,
you look at it across industry wide, it's like,
massive.
what would you think? It's like it's like 20% more, 50% more, or 10x, 100x.
See, from a let's look at two line items in the manufacturing industry. I mean, three line items, right? Energy cost, maintenance cost, reliability cost, and let's look at the revenue. So the cost side, there are two line items. Energy cost, in my opinion, really you can bring it down by at least 5%, which is huge, right? 5% of
5% is
last,
insane. Very
yeah,
large.
easily 5% is definitely possible, because today you have no eyes to spot bad actors in the system, right? Second is maintenance costs itself. It's a, I would say, very very no, archaic process. No, somebody hacked it out. No, you should be. I mean, you should be able to really troubleshoot it, right? And that's number two. Number three is on the revenue side of the balance sheet, right? There are two components out there. One is, let's say, if the crude distillation unit does not go down, I could produce at least 7 to 8% more, in my opinion. That's huge unlock in, in refinery products, for example, right? And the second is from an OEM point of view, it's a new revenue stream itself in that balance sheet. Digital services value added. That's definitely 8 to 12%.
Got it.
And
Got it.
if you look
So,
at just to give you an example, right? If you look at Bangalore itself, it's in a way it's becoming the global industrial monitoring hub. You
oh,
have
is it?
Shell.
Okay.
Yeah, yeah, yeah. Shell is monitoring the health of all equipments from here. Okay,
Wow, I didn't know that.
globally, all rotating equipments are slowly getting monitored. They started with a simple pump motor, slowly upping the game, and they want to
Wow,
have eyes on all the assets. So somebody's drilling for oil in Kazakhstan. This guy's monitored from here. Okay,
amazing.
near airport road. And if you look at what ABB is doing, ABB near Jalahali, right? They have a center where they're monitoring the energy consumption of government offices in Germany. After the Ukraine war, right? Price of energy went up. So they gave a contract to ABB, says you babysit and watch all government offices, have eyes on all of this, and anytime somebody's guzzling, so Jalahali, they're monitoring energy consumption in Germany. And then today you have Chevron, no, Belandur side, they set up a large industrial digital command center. They moved some of their operational executives, not their IT team. It's the operational executives they are relocated to Bangalore. They're starting to run digital operations from here. So if you look at it, industrial monitoring as a service is really picking it up.
That's fantastic. I mean, I didn't know that Bangalore
Yeah,
is becoming the hub for
yeah,
monitoring industrial stuff worldwide. That's huge. Now, when we come to CXOs buying, right? One, of course, you said you were earlier selling middle up, and then now you're selling top down because of also being bought by Accenture and therefore having access to the top down. But I think a lot of these end companies, not the OEMs, but the end customers, they were how skeptical were they of AI capabilities and values 3 or 5 years ago, and what has changed now? Uh, has it changed from? And yeah, I'll have some follow-on questions, but has their attitude of buying changed, or is it still like a very laggard industry kind of an attitude where show me, then I'll think about it? How has that changed?
No, I think there's a growing realization that the margins you make and the degree of digitization are kind of correlated. I can anecdotally talk about it. You know, Sometime back, we were talking to this CEO of a large pharma company, and he was given the benchmark saying that if you compare yourself against competitors, yours is roughly about 18 to 21%. That's where your profitability lies. But if you look at the leaders in pharma, even in India, they are 35 plus to 40 range in terms of margin. And the only difference was the degree of digitization. What discriminated the profitable manufacturing operations from the non-profitable one was the degree of digitization and AI they invested in. So the CEOs really bought into it because there is historical data now. Where earlier they were skeptical because it was very intangible, but now they're saying there is a degree of co-remain. Last 3-4 years, people are able to see the result of their investments. So there is an inference and correlation between the amount of digitization in AI and its effect on the market, right at the CEO and the board level. And again, we have seen many large companies, especially after the Gen AI one, I would say not before the traditional AI, Gen AI after the Gen AI hype, I think it's become a board level item. They want to be educated on what is the value unlock Gen AI could bring to their operations. So a lot of workshops happening. So there is a definitely an elevation in the messaging, a lot of interest, and they're ready to put skin in the game in terms of spending because they figure out if you don't put money into it, you're going to be behind the race. That realization is definitely there today.
Got it. So how does this change the buying behavior in terms of when we look at earlier, what would they ask for versus what do they ask for today from a startup that's coming to them?
Yeah, see, earlier it was all about POCs and let's look at it, right? Let's see it. So it'll be like 150, 200K POCs and nothing happens. Today, I think they're saying, okay, let's do the POCs. Definitely it's there. But parallelly, they are investing in the foundational data track because nobody has got that right, especially in manufacturing. So it's in various shapes and forms. Maybe there's no data capture mechanism. Equipment is not instrumented. You need to put the instrumentation layer on top of it. Defect data capture, defect 360 data lakes. I think is a big opportunity. You have, if you want to reduce defects, you have to learn from defects, but you don't have a critical mass of defect data, and there's leakage in that. So just building defect data lakes is a huge opportunity. So in a way, I'm seeing massive investment in the underlying infrastructure to collect sensor data and defect data because they do realize that it'll pay itself up in the next couple of months. Earlier, the realization was it's money being spent. I don't see the value in it. Okay, why to make this huge investment? But now they're saying it's an existential pressure for them.
Very good. That's very good news, right? Because these are industries that are that are the life of our planet in some way of human existence. At the same time, they're also killing the planet. And so if they don't have detailed data on what's going on, where they're using energy, where wastage is happening, all of that stuff, then there's no way to optimize that or solve for that. And the downstream impact is getting worse and
Absolutely.
worse over time. Right?
No, you're right. I
So
mean, pharma and refining industries are more regulated, right? So there's a regulatory pressure. There's a sword hanging over the leg. So they put
yeah.
money to build a data lakes and all of that. The other is a margin pressure. Yeah.
So from a earlier from a more of a cost reduction or a more of a hey, let's just see what this can do for us kind of a thing. Has it come to a position? I know you said it in different ways, but how do if a startup is getting in and wants to talk about the strategic value of doing this rather than just okay, try it and maybe it'll help you or stuff like that. How should somebody as a startup founder going to a manufacturing CXO, what should their approach be?
No, a simple thing would be to collect two data points. One is one should definitely map the as is user journey map. Right here is how maintenance happens today, step by step, micro task by task. Map out the as is process. Today we can say, hey, here is how the agentified process looks like, and here are friction points which are taken out. So if you are able to see a before and after user journey map for a task like maintenance, reliability engineering, process quality, emissions reporting, energy guzzling, I think that becomes very clear. I think the best way to sell AI is not to use the word AI. Oh, how you digital.
Okay, that's interesting. Okay.
Absolutely don't use it. Just show before and after journey. It's just a tool which is enabling that. If you ask how of course AI pops up, right? But we made the mistake because we are so attracted to the shiny new toys, digital twins, blah blah blah, right? So and nothing is tangible for them. They're used to buying things tangible, pump, motor, they can touch it, feel it, and this is completely intangible. And the
And
most
you're asking a lot of money for it.
and you're asking a lot of money for it, right? And you're not taking ownership of the outcome. They said, "Can you take ownership?" We're not taking ownership of that. Depends on it. So it was a little fuzzy affair. But I think the key thing is tangibility. Tangibility can come in two dimensions. One is clearly showing the change in the workflow and what it does. The second is translating that into very simple numbers. You need not even translate. So many a times it's very difficult to get financial metrics. So what we could do is just collect the lead indicator. In this case, for example, that OEM we talked about. So we know 12,000 troubleshooters can bring it down to 8,000 troubleshooters. 3.5 hours, you can bring it down to, let's say, even 2.5 hours. They immediately feel the math and they know, okay, we need not even, because that number is very difficult to get. But if you can give non-financial deltas before after, that's good enough.
Got it. Got it. Then we have a question, but we'll come back to that, right? From a procurement and implementation process perspective, right? Just going deeper and deeper into that, how has that changed for AI solutions in manufacturing 2 to 5 years ago to now?
2 to 5 years ago, they did not ask too much about the reliability of your applications, right? And security also didn't feature. Today, if you ask me, let's take for example, right? Everybody is talking about agents. So let's say there are like 10 agents, right? 10 troubleshooting agents. You could have Snyder come up with a troubleshooting agent. You could have a startup from India come up with a troubleshooting agent. That could be something coming on the consulting companies. How does the buyer differentiate it, right? The only way they can differentiate is by asking for proof points on the reliability of the agent. Okay, and there are a variety of metrics. So I think people have started asking questions on the reliability of the AI or the Gen AI models. Okay, and they want to get proof points. In some cases it's possible, some cases it's not possible. But they're getting smarter because that's where the rubber hits the road. Because this industrial mental model is very biased towards reliability. Anything they buy, they check the reliability. Now, reliability is becoming a front and center question for buying digital products. So, reliability in terms of the accuracy of the predictions, it could be, hey, you did a POC for like 5 machines or 10 machines. Now, I want to scale it to 500,000 machines. Will the product breakdown in terms of the scale? What is the inference time? So, they're really digging deep into reliability metrics of this product. So, that's a big difference, I would say. And the second way they're buying it is, at least some of them, I would say, and it's beginning of a trend, is they want to move into an outcome based modeling. When I say outcome based monitoring, I can give you an example, right? There's a glass manufacturing company which essentially said, I know how much energy is being guzzled across various subsystems in my manufacturing unit, and it's really a big drain on my balance sheet. I wanted to reduce it, and based on how much it reduces, I'll give you a certain percentage of it. So the initial phase of the project, the company put folks to go on Excel, to collect the data regarding. There's no instrumentation there. They collected the data, made a couple of interventions, and after those interventions they were able to see a movement of it and they were able to collect it. So even the Indian companies are going towards outcome based models for very specific use cases like energy guzzling, etc.
The challenge with that, Derek, is that you can give that reduction once, but you can't keep doing that reduction, no? So then how can you have an outcome based pricing for something like that?
So it'll be there'll be two line items, right? One is a steady state thing. One is a standard pricing which you'll anyway get, okay. And then there is it's like your fixed pay and variable pay. Fixed pay is always there, okay. The variable pay is predicted on the outcome.
Got it. So we have a question from the audience. I'll just see if we can put it here. Yeah, I think that's what we're talking about. So that fixed cost, how do you model? How do you think about? Variable is on the outcome, yes, so it works. But overall, it's no longer like number of seats or something like that, right? So what do you connect it to?
So the transition is beginning to happen, but I would not say it is fully gone there. See, to model cost would be a little difficult because those are intimate numbers a company would not reveal to a vendor, right? And you'll have to. So again, I would go back to this thing. Say they will be more willing to share the number of visits which are made, how many people they have, and you'll get certain proxies from that. So exact number you'll not get. Financial number, it's very difficult to do it, but all the lead indicator you can say what is the MTTR you can get the number of technicians you can get. You can get a reasonable assumption in reduction of both these numbers from them. They'll acknowledge that, and from that you'll have to infer the model. Exact numbers you'll not get. Proxies you'll have to use.
Got it. We have another question. Slightly longer question, but basically, if I summarize, he's saying, are there AI-driven solutions for Indian mid-sized manufacturers which can give a quick ROI because they have tight budgets and they can't do a lot of capital investment?
Yeah, India's a tough market. I would say in an ROI-based thing, the biggest use case which would sell is the quality diagnostics. They are not very much bothered about the asset part of side of things. Process quality, definitely they care about, and if they have data, it's easy to model. They're not very much bothered about emissions, sometimes energy consumption, not much bothered about safety. If you look at the 5 buckets of use cases, the arrowhead would be the quality use case. That is something, I mean, today with open source and stuff like that, I think price points are going down. It's very easy to support an Indian customer. Earlier, I would agree, it was very difficult. But I think with the democratization of a lot variety of tools, the tool cost itself will not be the big differentiator. I think the deepening of the vertical workflows would definitely be the differentiator, and the ability to quickly do something in 90 days.
Can you give an example of what you mean by deepening of the vertical workflow?
Okay, so how do you codify domain into a product, right? So multiple layers. So essentially, if you have an equipment, right? If I have a motor or a pump, I can have libraries of digital twins, right? Here are the signals I will get from it. Here are the state transitions. Here are the ways in which the equipment could die. So I could build a vertical library of such things. Now, the second thing I could do is I could verticalize the diagnostic. If a machine went down, I could have like 100 different types of diagnostics, out of the box diagnostics. And that library keeps growing every month on month based on the inputs from the subject matter experts, right? Vibration, you look for this signature. Flow rate, you look for this signature. And that becomes your real IP, right? So your library of signatures, your library of diagnostics, the library of digital twins, the library of failure prediction models for rotary assets, very specific to static assets, stuff like that. So those are the layers where you can actually start fusing together the electromechanical knowledge and the AI knowledge. Because, for example, a person who's dealing with rotating equipment, for example, will tell you that a very important predictor of failure is the number of times this rotating equipment deviates from your RPM torque curve. And that's only a knowledge which a domain expert would bring to the table. Statistically, for you to infer, it would take a long time. So fusing the physics, statistics, and heuristics is where the real verticalization is. So, for example, in a rotating equipment, I would say, hey, I'll increase the number of physics equations in it, which then correlate to the statistical models and the prediction accuracies.
We have a few more questions, right? Indranil asks, what would be top 3 variables that would be benchmarks for assessing AI impact in manufacturing?
In manufacturing, definitely percentage reduction in batch defects, reduction in spare parts inventory. Sometimes they keep spare parts for products which equipment they don't need to service. So it talks up a lot of cash. Spare parts. So if you can say that this machine is very reliable, it's not going to fail, you need not have spare parts for that. So reduction in inventory of that. And even the maintenance budgets, right? Today they have X people. So there are people today in refining industries who go and inspect an equipment when it's not required. So going from time-based inspection to health score and prediction-based accuracy dramatically brings down the cost of maintaining. So maintenance cost, quality cost, spare part cost.
Awesome. I don't know what this question means because I don't understand the acronym. Can we provide AI-driven solutions for measuring and improving OEE? I don't know what OEE is.
What is
Navneet, maybe you want to say what OEE is? Okay, we'll come back to that question later if Navneet is able to provide an explanation on what OEE is. But I had a question. last 2 years, 3 years, AI has gone from maybe first standard kid to sixth standard kid to now 12th standard kid and so on. And one of the things that you said was normal people who are outside of manufacturing will not know that the rotational how many times the rotational torque of the thing has exceeded a certain amount, and therefore it goes it's out of parameter, so that's proportional to the number of failures or whatever it is, right? So normal outsiders would not know that, but very soon AI is going to know that, right, if it doesn't know already. And let's say AGI as a thing is coming where it's going to be better than human across a wide variety of things. And when we look at specific areas, it's going to be even better than humans. Math, it's already better than humans. More areas like that, right? So what happens? What do we sell when the AI is smarter than us? Like, do you have any thoughts on that?
See, industrial, I honestly believe that because of the liability issues involved, there'll always be a human in the loop. Okay, so AI can recommend. Many a times, it will not be allowed to take a control action, change the speed. Very few cases starting to happen, but it will be a long way. It's a 10-year journey before AI closes the is allowed to control the loop, action loop. So there'll always be human. So that is one area I would say there is room for doing it. But I really don't know the answer. What will people do if it? It's a tough one. It's a tough one. It's yeah. It's no. It dramatically reduces the number of people. I mean, yeah. Now people do say that they can be redeployed into other areas and stuff like that. It's still an untested hypothesis.
Okay, let me frame the question in a different way. If you had AI that was smarter than humans in specific areas of manufacturing and what you are doing today, would you be able to employ those AIs? Where would you employ it?
Doing root cause analysis, right? Today, if any time you do root cause analysis, the human is limited by the amount of knowledge he has access to, and the number of variables he can process is also limited. But I think that is one place the number of variables it can, amount of knowledge is growing almost every day, right? It can learn from new data sources, and the number of variables it can process is also much more than human cognition, right? So that is one place I really think an agent, I mean, can see things which a human miss. And same thing is true for the X-ray defect testing, which we did at BHL Trichy, right? NDT testing, right? There were a lot of instances where the guy actually missed a spot where I caught it. Okay. Yeah, so it's almost like the radiological thing in healthcare, right? But I think it is able to see things we miss, both in terms of visual inspection as well as in terms of sensory inspection, I would say.
Got it. So the OEE is overall equipment effectiveness, essentially available capacity.
Definitely. I mean, I'll give you the example itself, right? So improving the equipment efficiency. So crude distillation unit is the most complex asset you can find, and there are hundreds of sensor variables which are getting emitted from that equipment. And there are a lot of these tiny turbulences which happen in that sensory data at certain points in time, right, which the human eye misses. And sensing that and responding to that is very important. And many a times what happens is, even if the system is sensing, there are some rudimentary alarms placed on it, right? That CDU emits a lot of alarms so that the human is immune to it. So he's saying alarm, hey, correct. So alarm prioritization is something which humans can't do better, whereas the agent can do better. So that's number one. Number two, it can see things, tiny turbulences, even within the operating envelope, right? You have an upper control limit and a lower control limit in which, let's say, a vibration happens. So if it doesn't breach, it doesn't give you an alarm. But within that range itself, even power fluctuations happen, and those can have an effect on that. So within that operating range, seeing this turbulence and fluctuation is something which algorithms can do much better than humans, which can have an effect on the overall efficiency.
I think one thing that you said was interesting to me. Are we till today the sensors that have been deployed also have been deployed with the perspective that some human is going to be seeing the output. Many of the sensors that are being deployed are not deployed from the perspective of, okay, what if an AI was looking at it?
Beautiful thought.
Do you think that is changing what kind of sensors are being deployed and where they're being deployed?
To be honest, I never thought of it that way. It's a good angle, actually. Uh, but one thing
Because
I've seen.
maybe where I'm coming from is like, let's take this rotational equipment, right? We may not have a simple sound sensor, very cheap, easy to digitize, easy to record, but a human may not be able to understand from the sound is it working or not. But maybe an AI can actually detect uh, more things from just the sound of the
That is true.
fan or whatever. Any thoughts about that?
No, no, you are right. So there are a couple of sound analytics companies which are trying to build the largest database of, I would say, sound signals from rotating equipments, right? So there are some cases where, yeah, what you said is true. There are some cases where the guy who's worked on the shopping line for like 25, 30 years, he will just listen to the equipment and say something needs to be done.
There's a
So
famous joke, right?
uh-huh. What happened?
You, you,
What
you
joke
must
was
have
that?
heard this one. So there's this a big manufacturing plant,
Hmm.
and there's this guy who's been working there for 25, 30 years, and he retires, right? And they give him a send off and stuff like that. A
Hmm.
few weeks later, the plant is not working,
Hmm.
and
Hmm.
people are not able to figure out what to do, right? And they say, okay, whenever this kind of stuff happens, the only person who can solve it is this guy. And so
Hmm.
they call him back and they're like, please, please help us fix it. So he comes into the plant and then he goes around and he has this hammer and he's going tongue, tongue on different things. He's going around and like knocking on a whole bunch of things. Then he comes back and he marks an X on one part and says, replace this part. And then he sends a nice, $10,000 bill for it. And
Oh,
then the guys ask, what is this? You just walked around the plant, you just like knocked on stuff with a hammer and you're giving me a $10,000 bill. And you have to tell us like what we're paying for. And he says, okay, I'll send you an itemized bill, right? And he says, knowing where to knock,
yes, yes. Absolutely, absolutely. So,
$9,950, right? And then X mark, $50.
no, so you're right. Understanding the nadi points, so to speak, in the equipment, right, where you can go and pinch it is very important. But going back to your original question, it's a very important area. So at least in the automotive industry, what I've seen is, at least in Whitefield, there's a lot of innovation happening in the automotive R&D labs. One area specifically is in vibration detection. Okay, earlier you would have to have an intrusive way of detecting it. It had to be embedded, and sometimes the data which comes out of it is not trustworthy. Now they're having very non-invasive sensing. They come up with sensors, proximity sensors which can sense. So non-invasive sensing is and tying it up to and designing it for agent is something which is an interesting area, I would say. Yeah.
Oh, that's fantastic. So we'll take one last question. On-prem versus cloud. Is that question dead or is it still alive?
So it'll out. So they don't like the word cloud in the energy industry. So they are. So it's a very sensitive thing. Many industries because they don't look at it as data being on the cloud. They look at it as their liability being on the cloud. Okay, right? When they miss an inspection, when they miss responding to alarm, those liability events are also available somewhere. So they will not want cloud. Okay, for many reasons. So it has to be in premise or private clouds, which they have complete control over.
Okay,
Okay.
so private cloud on AWS is fine.
Yeah, yeah. So, for example, Google Cloud has gone to the energy industry in Saudi Arabia and said everything will be done here, hosted out here, done. That's it, and you have complete control. That sovereign data thing, right? So nothing goes out. They don't want other countries to see, kind of thing. So it's super sensitive topic and various mechanisms to do that, but definitely a super sensitive topic.
Got it. Brilliant. With that, we'll close, Derek. Thank you so much for coming.
Thank you.
I hope for the listeners here, they got a bird's eye view of how AI has changed in the manufacturing industry over the last few years and how it's going to change in the next few and how they can, build AI in manufacturing. And on the 24th in Chennai, Derek will be there at the roundtable in manufacturing, where we'll be talking about if you are in that roundtable, you'll be brainstorming with Derek on what kind of areas in manufacturing where AI can make a massive difference and you can build $1 billion business out of it. And if you're lucky, maybe Derek will also help you build that $1 billion business in some way.
Wow. Big numbers. Thank you,
Yeah.
Prasanna. Thank you, Sas Bhumi. Would love to see you all in person in Chennai. Have a good evening.
Thank you. Bye.
AI is changing the world. Did you enjoy this episode? Subscribe so you don't miss the next one. We're on all the popular podcasting platforms. Leave us a comment with your questions and thoughts. I'd love to hear from you so we can go through this exciting journey together.